So, as part of the introduction to the wastewater treatment, I'm going to cover the reasons for treating wastewater, the NPDES program, which regulates wastewater treatment, and finally, it will include a discussion on the individual elements of wastewater management. So, now let's look at the reasons for treating wastewater. Wastewater is essentially used water from home and industries. Typically, the wastewater is treated and returned back into the environment, and it's returned into receiving waters such as lakes, rivers, and oceans. Primarily, wastewater is treated for removing organic pollutants, the inorganic pollutants, which include nutrients for plant growth, such as nitrogen and phosphorus, and for removing pathogenic, which are the disease causing organisms. So, primarily, wastewater treatment is for the protection of the environment and human health. So, in the receiving waters where the treated wastewater is discharged, adequate oxygen needs to be present and maintained to ensure the existence of its normal aquatic life, including fish. And if the wastewater that is discharged into that water body is not adequately treated, eutrophication, which is the oxygen depletion of the receiving waters, may occur because plant nutrients, which include nitrogen and phosphorus, if present in the treated wastewater, would promote plant and algae growth. The decay of these plant and algae would cause the oxygen depletion. Additionally, if any residual organic material is present in the treated wastewater, it would be consumed by the aerobic bacteria, resulting in the consumption of dissolved oxygen. The NPDES program, which is the National Pollutant Discharge Elimination System program, is the federal regulations which regulate the wastewater treatment operations. NPDES was established under the 1972 Clean Water Act, and it applies to all sources that discharge pollutants into the waters of the United States. Primarily, the NPDES requires all facilities that discharge pollutants into any body of water to obtain and comply with the NPDES permit. And the NPDES permit is the document which establishes the discharge limits, the monitoring and reporting requirements for each of the entity that treats wastewater. The permitting and the enforcement responsibilities of the NPDES permit is delegated by the EPA to individual states for implementation through their water board. NPDES implementation hierarchy is as follows. The EPA was granted the overarching responsibility to implement and monitor the NPDES program by the 1972 Clean Air Act. And the EPA has delegated its responsibility for the NPDES implementation oversight to the state EPAs. So in California, it is the California EPA which has the responsibility for the NPDES program, and the California EPA subsequently delegates that responsibility to the State Water Resource Control Board, and the State Water Resource Control Board delegates its responsibility to the Regional Water Quality Control Board. So there are in all 9 regional water quality control boards. So for the Orange County Inland Empire area, it is the WQCB Region 8 or the Santa Ana Regional Water Quality Control Board to run the NPDES program. So now let's talk about the elements of wastewater management. The first element is the generation or the creation of the wastewater. The second element is collections. This deals with the gathering and transportation of the wastewater from the generation sources to the wastewater treatment plant. The third element is the treatment process by which the wastewater is treated, and then followed by the final element, which is basically the disposal or reuse of the treated wastewater. So now let's talk about generation of raw sewage or wastewater. Wastewater is used water and water carried waste from homes and industry that flow through the sewers to a wastewater treatment plant. The wastewater can originate from homes, and this is the domestic sewage, and this is the wastewater derived primarily from dwellings, business buildings, institutions, etc. Another source of wastewater is the liquid waste from industry, which is the industrial sewage. The industry derived sewage, by virtue of its origin, could potentially be of higher strength, which is higher level of pollutant concentrations compared to the domestic sewage. So the collection systems can be classified into two types. The first is the separated sewer, and the second is the combined sewer. In a separated sewer, the stormwater from surface runoffs and roof drains are collected and transported to local receiving waters for surface water discharge. Here in the system, the used wastewater generated from homes and industries, including washing, waste, bathrooms, are collected in separate pipes, and these pipes convey the wastewater to the treatment plant. In the combined sewer, you basically have the storm water and the wastewater essentially combined in a common pipe and transported to the treatment plant for treatment. In summary, in the separated system, the stormwater and wastewater are transported independently for ultimate disposal, whereas in the combined sewer, you have the commingling of the storm and wastewater, and this combined is transported to the treatment plant. So now let's look at treatment. As we have stated before, that the objective of treatment is so that we could safely discharge the treated wastewater into a water body. Additionally, especially nowadays, treatment is expected to provide means to recover resources from the wastewater. So now let's see how wastewater is treated in a typical plant. The influent wastewater is first treated in the preliminary treatment. The solids that come out of the preliminary treatment are loaded into trucks and hauled off to a landfill. The water from the preliminary treatment goes to the primary treatment in the primary clarifiers or sedimentation basins. The primary treated water then flows into the secondary treatment. The activated sludge secondary treatment process is shown here. After the secondary treatment, the treated water is either discharged or treated further as part of the tertiary treatment. These solids that are removed from the primary and secondary treatment processes need to be stabilized prior to disposal or reuse. Digestion, a commonly used solid stabilization method, is shown here. The stabilized solids which come from the digesters are dewatered and hauled offsite for reuse or disposal. The anaerobic digestion, if used, produces gas which contains methane and can be used as fuel. And now the final element of wastewater management. The treated wastewater can be disposed by reintroducing it back to the environment, or it can be reused. The disposal methods include surface water discharge or the subsurface water discharge. The reuse options include potable water reuse, in which there is the indirect potable reuse, which involves blending with groundwater or surface water and then reclaiming it and treating it further for drinking or potable water use. The other is the direct potable reuse, where the treated wastewater is subject to advanced treatment and then introduced directly into the municipal water supply system. Reuse can also be done through water reclamation for irrigation or industrial use, and land application for beneficial reuse, primarily for agricultural purposes. So, a new perspective has emerged with respect to wastewater treatment, mainly because significant resources are involved as part of the wastewater treatment. Water is now seen not as waste water, but is seen as a resource for energy production, reusable water, and as a source of recoverable valuable materials, including phosphorus. Now, there is a nomenclature shift from wastewater treatment plant to a renewable resource recovery facility, which is a facility that produces clean water, recovers energy, and regenerates nutrients.